1 second here. Let me share some screen to give you guys. Can you guys see that?
Yes.
Yes.
Awesome. So one of the programs we've been developing with Evigence are freshness management programs, and that's what I wanted to get into today. And the main focus of that is helping clients increase sales and reduce costs by improving their freshness management. And part of that, I should say a large portion of that is helping to reduce food waste via the sensors that Evigence makes. Now, the question here is, okay, perfect. So just to give you guys a little bit of background as you look at kind of this fun graphic, what Evigence makes are printable sensors that show the freshness level of products they're attached to via a simple visual color change. So if you guys can think of, right now we're using date codes, which simply have a date and perhaps a time and show which product they're attached to, but they don't show the actual shelf life and usable quality of that product given the time and temperature that the product is exposed to. So some examples that I wanted to show you really quickly are this right here, which is a green to red sensor, right? Here's another one that's a silver to yellow sensor. So these are smart labels, which in the near future, in numerous categories, could replace the date code system that we currently have, as they're a lot more accurate in terms of showing product quality, and they can be a lot more user-friendly in terms of showing exactly what to be doing with the product given the color on the sensor. But getting back to the presentation for a minute, that leaking pipeline, where do we see loss in shelf life and loss in product quality? Well, really it's due to breaks in the cold chain and the supply chain. And that's what you see here. From manufacturer to DC, from DC to retailer, and then from retailer to home, all of those have certain components which are exposing products to potential abuse and therefore reducing shelf life, right? And if you guys can see this, this is really interesting. So looking at products that were produced, manufactured, boxed in the same facility, shipped on the same day to the same store. So how is it that they have two different colors on their sensor? Right? So it's due to those changes or the variability that's happening in transport and in merchandising that can drastically change the usable shelf life of the product, which is shown by the color change in the sensors that Evigence makes. Some of the categories that we're looking at are floral, bakery, prepared foods. Again, these are all fresh categories. And if people are raising their hand, I am not 100% familiar with that function. Maybe I need to expand this, but Alexa, if that's happening, please just let me know. These are a few of the categories we're getting into. And there's a number of ways that we can add value in these categories. And this is specifically in retail, because that's what I've been focusing on. However, we also have traction in healthcare and in a few other verticals like cosmetics and health and beauty. Unit level cold chain management is what we're preaching. That prior to today, there has not been a visual indicator on unit level that's cost effective, that allows not only the consumer, but potentially every member of the supply chain and cold chain to see the product quality and freshness throughout the chain. And so as you guys can see, what that causes is behavior change, decreased waste, increased awareness, and fresher products. Looking at this in more of a numbers or numerical context, when we're talking about the bottom line, I'll just go through a few of these on the left-hand side. But improving product quality and consistency is very important when you're talking about perishable goods, whether that's a mascara or whether that's a box of strawberries. Consumers pay for consistency and it increases loyalty. We can maximize the shelf life of products by adding safety days. So imagine that if you have a bag of lettuce, and because the manufacturer is unsure of the quality of its cold chain, he's going to give as conservative an estimate as possible as to the shelf life of that product so that nothing goes brown or spoils. Well, if we can create more visibility in that cold chain and we can add a day or two onto the shelf life of that product, or 10% to 20% of the shelf life, it makes a drastic difference. Another thing that you can do is based on the quality and the life, you can present a dynamic pricing program, right? We're seeing that with flowers right now. When flowers reach half their shelf life, the sensor changes color and hence they're merchandised and priced differently.
Zach, you have about 1 minute left. They're a little less.
Perfect. Yep. These are some of the categories better explained. As I said, all fresh categories in retail. And then the only other part that I wanted to explain briefly was we've created an app as well, which is a digital layer or a platform which can read the sensors. And essentially what it does is it reads the color of the sensor and it translates that into a usable shelf life that can be either transmitted into a retail system in a B2B setting, or it can communicate with the consumer. So imagine if you have leftovers and you don't remember when you put those leftovers in the fridge, you could scan the sensor and it would tell you that you have 2 days left based on when you put those leftovers in the fridge. This gets into a little bit more of how we can apply that digital layer from a geo-tracking standpoint and an analysis standpoint. And then to summarize, we do have pilots in 3 different continents right now, in 3 different verticals, those being hygiene, health and beauty, cosmetics, healthcare, and then also in food retail. Investors of ours include the Landa Group, which you guys may know from digital printing and Hewlett-Packard. And some of the clients that we're working with in the world include McDonald's, Kroger, and X5 in Russia. And with that, I didn't know if I was supposed to finish or if you had questions on top of that 5 minutes.
I was told we can take questions. Is that correct, Jacob?
Yeah, so if anyone wants to just ask in the chat or DM myself or Alexa or Zach, they're welcome to. So far, I don't see any questions.
Or just start let us know you want to talk, and
or just
we'll unmute you, right?
Yeah,
Can we do it that way, Jacob?
Yeah, you could unmute yourselves, maybe.
All right, you can unmute yourself.
Yeah.
We got a hand. I like the old-fashioned hand. Lawrence.
Yeah.
You got
so a sensor on a carton is one thing, but once you take the product out of the carton and put it on the store shelf, how does that translate?
Right. So these sensors are approved for secondary packaging. So you would have to have, you would either use it at a case level on a box, or let's say a clamshell or other containers that are put on a shelf. But on actual product skin, that's not our business.
I had a question for you, Zach. How about, I'm sure you've done some pricing analysis, right? So that's probably your biggest barrier right now. The date stamps that we all know are completely misinterpreted. Well, that's more for the consumer. You're dealing with the supply chain handlers. What is the price differential? How are you overcoming that barrier?
Yeah, very good question. And I think it's one that we encounter a lot because as big of a problem as the date code is, yeah, the industry and the FMI and some of the other institutes are looking at how they can help, but with no concrete solution. And we're getting towards that in terms of governmental compliance and whatnot. But more specifically, yeah, there's a difference of maybe a cent or two in terms of your per label cost. But if you look at the cost of the goods that it's put on and the rate of decay, meaning your markdown rate or
We lost you unless other folks can hear Zach.
No.
Zach, if you're back, can you repeat the last sentence, please? We lost you, Zach. Okay. Hopefully he will come back to us. Anybody else have thoughts? Obviously, hopefully Zach can hear us. Less of a question because we don't have the guy going to answer. But
I think in the interest of time, we'll move on to the next
Okay,
topic.
on the interest of time, we're moving on. Okay, so the next speaker is Jacky. He is the CEO of Nutrilees. I hope I'm pronouncing that correctly. Nutrilees is an upcycling industrial wine residue company. It's turning it into food produce. Very interesting. Jacky, let's hear it. Please.
I guess it should share a screen.
There
thank
you
you
are.
all for being here.
There you are, Jacky. Hi.
Hi.
I can hear you now. You're gonna share a presentation or just talk? Okay.
Let's see a presentation. Let's see if it works. Okay.
Excellent.
Okay, great. So basically, I believe that we all know the phrase turning garbage into gold. Well, we are actually doing it. More precisely, we are turning the wine industry waste into superfood, highly nutritional, sustainable, and affordable food source. We offer value to three major sectors. Nutrilees technology will increase wineries' profitability. We will supply the food industry with a tasteless, and I emphasize here, a tasteless and affordable superfood. And we will provide new age consumers a tasty and upcycled ingredient food products. A few words about myself. My name is Jacky. I'm the CEO of Nutrilees. In my previous position, I was the CEO of the company in Israel for 7 years, growing the company from its founding to a successful acquisition. Since the beginning of wine production about 5,000 years ago, this wine sludge, and it looks like sludge, a purple sludge, lees, is simply disposed of and damages the environment. This sludge, contains mainly yeast and grape leftovers. It is very sour, very bitter, and smelly. And usually wineries spend a lot of money to manage this garbage. In 2018, Dr. Meir Schlesel, who is attending the session here, a wine researcher at the Tel Hai College and a senior faculty member at the food faculty, started to check what he can do with lees with his student Yochanan Gerber. Both of them are the founders of Nutrilees. They converted Nutrilees to, they converted the lees to Nutrilees to a tasteless powder loaded with proteins, dietary fibers, and minerals, basically a superfood. We set up Nutrilees, the company, in 2019 raised 1 million shekels and partnered with IFF. IFF is a global supplier to the food industry. The modern wine industry generates about 1,350,000 tons of sludge globally every year. It's a huge amount of waste of sludge. Using our technology, we will turn it into about 350,000 tons of high quality superfoods with a potential of $2 billion in sales. In 2020, we started the incubator program held with by the Israel Innovation Authority. And within 9 months, we completed a standard process and optimized it. We started the regulatory registration process and submitted patent applications. And we began to talk with Ferrero and Hershey as our first customers. In 2020 also, we tried Nutrilees superfood in different food types in-house in our lab, like pasta, cookies, protein bars, savory snacks, and burgers. The results were quite outstanding. Nutrilees improved the nutritional values of the products without compromising the original flavor of the products. There is an excellent team behind the company. It is a multidisciplinary and a very versatile team, both from Nutrilees and IFF, who are responsible for this accomplishment so far. Next, we will complete the regulatory certification and extract proteins from lees. We will develop consumer food products with Nutrilees Superfood, and we will apply the technology to other food industry waste streams. And for that, we are raising $2.5 million. Other superfoods use valuable and expensive resources to get the same results as Nutrilees. We do more with less. We use less soil, less water, and the outcome is highly nutritional, extremely sustainable, and affordable food source. Basically, this is what Nutrilees is about, turning garbage into gold. And for more details, you are invited to join me tomorrow to one-on-one sessions or any questions. Thank you.
Thank you, Jacky. That was very interesting and informative. Definitely applies to California for sure. Do we have any questions from the audience? You can either, oh, there, Lawrence. I'm only seeing like 6 people on my screen, so go ahead, Lawrence.
Yeah, of the waste that you're going to be capturing, or the product that you're attempting to capture, what % is used at all now in some way or form, and what % is literally wasted?
Well, about 99.9% of it is wasted, because since it's very sour and bitter, there is nearly no usage for it. And most wineries just dispose of it in different ways. It depends on the regulatory in each country, but basically, there is some wineries that extract some tartaric acid for the wineries usage, but it's not huge numbers, and it's nothing significant.
Thank you.
Great. We have another question from Somi Ray, if I'm pronouncing your name correctly. Would you like to unmute yourself and ask a question?
Hi. My name is Shomi Ray. I'm from Campbell Soup Company, New Jersey. So it's a great project. Quick question on I know you mentioned the flavor. It is like flavorless, it is tasteless, but what about the color? Is it like the purplish, dark purple color that the pasta you showed us? Is that the color of the powder?
Yes, well, if the waste, the lees, is from red wines, it has a typical red wineish color. Some like it very much in application. In the application that if I'll go back to just a second. Okay, I'll just share it once again. If you'll see where is it? Can you see it?
Yeah.
Yeah, this is the color of pasta with Nutrilees superfood at about 10% of Nutrilees in the pasta. So this is the color that the pasta get.
Okay.
Some like it in the food, some other people don't like it so much. It depends on the application of the powder.
Right. My next question is, what is the shelf life? Do you have any idea around that?
Well, since we deliver it in a dry, as a dry component, as flour, we believe it won't be less than 12 months.
Okay. And
I think in the interest of time, sorry to cut you off, but Sumi, we really invite you to set up a one-on-one meeting tomorrow with the link in the chat.
Sure.
So that we could give all the companies kind of an equal opportunity here today without anyone waiting.
Not a problem. Thank you.
Thank you so much.
All right. Thank you, Jacky. We are going to move on to our next speaker. His name is Ohad Polak. He's with a company called Seebo. It's a solution to predict quality and yield and prevent waste. Welcome, Ohad Polak. He's the VP of Marketing.
Thank you very much. Happy to be here. Can you see my screen?
Yes.
Okay, let me upload the presentation. Okay, so hello, my name is Ohad Polak and I'm the VP Marketing at Seebo. I'm very happy to be here and introduce you very briefly the Seebo solution. Seebo is the predictive quality and waste solution. Seebo works to reveal the hidden causes of production losses using process-based artificial intelligence, which is a proprietary technology we developed. And our main focus is waste and quality problem in the manufacturing process. Using Seebo, we help manufacturing team to prevent quality and waste losses. Here are some examples of losses that we often see in food manufacturers' plants. For example, net weight, underweight, size, shape variabilities, quality variabilities, raw material variabilities, reject due to weights. And there is usually one common source for those problems, that this is process inefficiencies that occur during the manufacturing process. To tackle these process inefficiencies, manufacturing teams have to answer three main questions. The first one is, why do process inefficiencies happen? The second is how to prevent those process inefficiencies. And when should they take preventive action in order to eliminate those process inefficiencies? The Seebo solution enables manufacturing teams to pinpoint the primary suspects for manufacturing losses. And we're doing it by providing an automated root cause analysis. Using predictive recommendation, we discover the process expert, what are the best optimal process setting. And finally, with proactive alerts, we let manufacturing team to know precisely when to act and prevent those losses. Together, all these capabilities empower manufacturing team to master their process, and they are doing it by using artificial intelligence. Seebo is recognized as a Gartner Cool vendor. We are strategic partner of Microsoft, and this year Seebo has been selected as a technology pioneer by the World Economic Forum. This is a very prestigious award. Among the previous recipients, you can find companies, small companies like Google, Twitter, Spotify, and Airbnb. And now we are part of this, I would say, team and working on smart manufacturing and about the future of smart manufacturing. Leading global manufacturers and mainly food manufacturers using Seebo, and we are very proud to have these names and customers among our list of companies like Mondelez, Nestle, Barilla, PepsiCo, Strauss Group in Israel, CPW, Lindt, and many others. But we also serve customers from the chemical world and the automotive world, and from other domains like glass and cement. But our main focus as for today is food manufacturing. Here you can see what Nestle, head of continuous improvement, had to say about Seebo. And if you go to our website, you can see the full testimonial by Nestle. As I stated, Seebo is a pioneer in process-based artificial intelligence for manufacturers. I don't have the time to review with you and about what is behind process artificial intelligence, what are the elements that we see in the core elements in process artificial intelligence. I would be very happy to do it in tomorrow, if you like, of course. But I would like to summarize with our key benefits. So Seebo designed specifically for quality and waste losses. We help manufacturers to reveal the hidden causes for losses. We continuously adapt to changes in the manufacturing process, which in many cases it's very dynamic. So we continuously analyzing 24/7 the manufacturing process and adapt to changes and provide more and more insights. We provide artificial intelligence that production team can actually use. This is one of our core elements because we can provide many smart insights, but if manufacturing team cannot use it, it's useless. So we invested a lot in best practices and use the interface that bridge the gap between the sophistication of artificial intelligence to the level of and the expertise of manufacturing team. They don't have to be data scientists. And the solution is very scalable, and it's very easy to scale across plants and manufacturing line. So I will be very happy to broader discussion tomorrow or in any other time. If you are food manufacturers, if you are doing continuous manufacturing or continuous batch manufacturing, we are a perfect fit for this type of manufacturing, and very keen to have some more discussion about it. Thank you.
Thank you, Ohad. Appreciate that. Any questions? Somi, your hand is still raised. I'm assuming that's from previous. If not,
I'm sorry. Yes,
let us know. No problem. It may not be a quick question, but I do have a question for you, Ohad. It would be great to understand. I know you said you didn't have enough time, but could you give us an example of an actual product that's running through this process that you're eliminating waste, and how does it work in real life? I get that you're using AI. I know it's pretty abstract, but could you give us a rough idea? Like take us on an example.
Okay, so for example, we can talk about bars. Bars.
Mm-hmm.
So we have one of our customers, they produce millions of bars a day.
Yes.
And those bars, they have all kinds of quality problems with significant percentage. They get bars with, they are too fat, too low, different weights, and they have to throw them away, and they can't
standardize
use them. Yeah. So what we are doing, we actually collect all the information, all the data from the manufacturing line. It can be data about the raw material. It can be manufacturing, what we call time series data. Sometimes it can be up to thousands of data tags in the process. We get it from all the machines, from all the collecting from all the systems that involved in the process. We collect information from sensors in the process and inject it to a scheme, to a dedicated scheme. And then on top of it, we are doing some of modeling of the process, of the topology of the plant. And together with all the data and the topology, we create we're doing some data enrichment to understand all the connection, all the relation between the different phases within the process. And this is used by our core AI engine that was designed specifically for process manufacturing. And this core process algorithm can understand all the complexities like buffers and loops and parallel and multi-product changes in products. But in a nutshell, after all this data crunches by this machine learning algorithm, taking into consideration the context of the specific production line, it produces insights for ortho root cause analysis about the different problems and the factors for the problems that are based on multi-factors and the recommendation and alerts, and it's all streamlined to the production team and for the process expert. So I hope it helps you.
That helps. Thank you. What I'm understanding is your technology creates analysis on inconsistencies within the system and identifies where the inconsistencies occur to create more standardization throughout the product line. Is that somewhat what you're describing?
It might be, but we might, in many cases, you have at the end of the production, you have a sensor that gives you the quality of each, or the average quality of the output. And then we look back and all factors, to all the relationship, second derivative, third derivative, and we understand if there is connection between the temperature in the oven and the speed of conveyor and the raw materials, specific raw materials. Today in the Corona, we see our customers that there is changes in the supply chains and the raw materials changes, and there are changes whether for seasonal changes between winter and summer. And all this connection that sometimes involve many, many factors, we provide and provide some insight about it for process expert in order to improve the production process and eliminate waste.
Excellent, thank you. Any other questions? I'm scanning the participant list. There are no hands up,
yes.
And I'm looking.
Lawrence has
one quick
Lawrence.
question.
Yes,
no.
Lawrence. You don't do the electronic hand.
Yeah, it's quicker. In even the best companies, multi-billion-dollar food companies, there's always waste. There's always issues with quality. And contamination, of course, is part of that as well. Part A, do you cover contamination as well? And B, overall, in companies that are presumably optimizing process, what percentage in these best managed companies can you improve? 5%, 10%, 2%?
Okay. So first of all, I totally agree with you. This is a major pain. The waste is persistent, okay? And we call it the complexity gap because they have the goal, our customers, VP manufacturing, director of operational excellence, all these guys, they have a goal to achieve a level of waste and reduce the waste. So it really depends on the lines, and sometimes we're coming to customers and say, guys, we can't help you. It's, we will not be able to eliminate, or we are not eliminate, we reduce the waste. From our experience, we can reduce waste in 60, 70% reducing waste, or improve quality, or improve yield. So there are lines that we are coming and we see that there is a waste level of 7%, 8%. And over time, we are able to reduce it to 3%, something like that. What's very interesting to see that many food manufacturers until today, they don't really looked on the entire data, okay? It was for some reason, it was difficult for them. In the chemical industry, for instance, they are very advanced because of regulation, etc. So they always look on the entire data, gather it to all the data. And today we are coming to many advanced, very tier 1 manufacturers. And the first thing we do is to gather all the information. Only from the gathering, and this is already a big jump to reduce waste and improve performance. I can't hear you.
Thank you. I'm not currently on your list. I'm going to add you for a meeting tomorrow, but thank you. Very interesting.
Thank you, Ohad. I appreciate your presentation. We are going to move on to the next speaker. The next speaker, his name is Amir Oranim. Sorry, I'm going to get it right. He is with the company TripleW. It's an upcycle food waste company. Takes food waste and turns it into a high-value bioplastic. And Amir is the co-CEO. Please take it away.
Yeah, thank you. Thanks a lot, Alexa. So, hi, everyone. My name is Amir Oranim, co-CEO of TripleW, and we're making waste history. Basically, TripleW stands on 3 pillars. The first is to maximize the valorization of food waste. I heard some the lectures before, Robin Food and other speakers that talked about how, for example, they can take food waste and make it edible. But we basically deal with food waste which is not edible anymore, and will be landfilled or incinerated or composted, or in the best case will be anaerobic digested. I will explain in a second. So we maximize the value of the food waste by, instead of doing all of these, we can make bioplastics from these food waste. The second pillar is the bioplastics. Currently, bioplastics exist. They replace traditional plastics in many applications, but the issue with that is that they are still more expensive than traditional foliar-based plastics. By using food waste as feedstock, we can reduce the production cost significantly. And the last pillar will be the environment footprint, that in our process, we have a negative footprint. So basically the process that we use, we develop, absorbs more CO2 and greenhouse gases than it emits. So as I mentioned, the real issue of food waste is that it's not valorized in a very good way. It's been incinerated. With incineration of food waste, it would not be allowed in the EU from 2023. It could be landfill, which is obviously the worst alternative. And if if it's another alternative, it's an anaerobic digestion, which may produce biogas, which is a more environmental alternative, obviously, but it's still very, very dependent on government subsidies. And without it, it doesn't economically feasible. And when you look at the bioplastic market, then you should know bioplastic market exists. Bioplastic is a plastic that is made from, which is bio-based or biodegradable. We produce PLA from the food waste, which is with both biodegradable and bio-based. The problem with the bioplastic price is that it's high due to the high cost of purchasing corn and sugar cane, from which bioplastic and PLA are currently manufactured. But we basically take this problem off the table as we produce it from food waste, and we basically can be based wherever there's enough food waste, which is everywhere. We don't need to be located in Thailand where the sugar price is very low, and we don't need to be located in places in the US where the corn price is subsidized. We can do a local manufacturing of lactic acid and PLA where there's enough feedstock. So basically, as I mentioned earlier, the first product that we produce in the fermentation process is lactic acid. From lactic acid, we can use off-the-shelf polymerization technologies to go all the way to PLA. And we also developed a way to bring back PLA waste to the process, produce more lactic acid. So we close the loop in many, many ways. We can offer companies to take their food waste and bring it back as products, as for example, food packaging. And we close another circle by not only providing customers with PLA food packaging, but also take these food packaging waste, the PLA waste, back to the process and goes all the time. It's like a closed loop. We have some byproducts like lipids and compost. We can generate significant revenue and basically much more than anaerobic digestion make per ton of waste. We can reduce the production price of PLA by at least 30% because we're using food waste. And this is for an example for a life cycle analysis that we made, which showed that for every kilo of lactic acid, we can save 0.7 in CO2. We are currently working with a partner in Belgium, Group of the Big, which treats over 150,000 tons per year of food waste. The food waste is coming from logistics centers and from the port of Antwerp and from supermarket chains. It's currently Group of the Big has an anaerobic digestion, which take this food waste, turn it into biogas, and then to produce electricity. We are constructing a demo facility in their backyard with their in-kind investment of place, equipment, and engineers. And the goal is once this demo is over and completed, then we can go to a full-scale facility and retrofit their current facility. We also, we also have some activity in the US. We are negotiating another demo and retrofit of a major anaerobic digestion facility, as we do in Belgium, and we assume that the total retrofit project will be around $25 million. We already proved some pilot testing which we made in a place called Bio-Based European Pilot Plant in Ghent, Belgium. This is how we got to Belgium, and this is why we build all the ecosystem in Belgium, in the Flanders region. we also have an interdisciplinary team. The process is starting with the biology process fermentation and then ends with downstream processing, which is more of chemistry. Yeah, and we have people with a lot of experience in their field. We have employees already in Belgium running the demo. Our CTO has more than 2 decades of experience in fermentation processes. So, I mean, our next step is to have a full-scale facility up and running, and in that way we can start generating significant revenues. Thank you.
Thank you, Amir. Do we have any questions from the audience? You are all pretty quiet. Let's see.
Question?
Please, Nick, go ahead.
Thank you. So first of all, Amir, it's great. Any bioplastic is better than regular plastic. I'm curious about what is the percentage of the uneatable food waste there is, which is the part of the food waste you are going to transform to plastic, and how you are planning to reach all this food.
Yeah. Okay, so I'll answer quickly so to let the other speakers have time for their presentations, but just regarding your question. So basically, for example, in Obdebik, everything that is going in the facility is not edible. It could be food waste that was disqualified because there was some kind of leach spilled on the pineapples or whatever. It didn't pass quality control. We saw molasses, a lot of molasses there, all over the place because doing in the way from I don't know where to Antwerp, it was all messed up. So basically, to your question, 100% of this food waste is not edible. I can tell you that, for example, in the site, they do not allow the employees to touch it. I mean, it's against the law to even consider eating it. So this is for the first question. And the second question, basically, there are many hundreds, thousands of anaerobic digestion facilities which treat millions of tons of food waste. And our go-to-market strategy is to identify all the relevant anaerobic digestion facilities and go there, implement the process in their facility using their utilities, using everything that they already have there, and just maximize the revenues. And yeah.
Great, thank you. I have just one last quick question. The products that you're producing are made of PLA. Can they be composted or anaerobically digested at the end of life?
So the answer is divided to 2. First, yes, by PLA can be, if it's collected to industrial composter, then it could be, it will biodegrade. Obviously, everyone will tell you that nah, it won't work. If it goes to the ocean, it won't biodegrade. But I can tell you that if there will be more PLA in the market, then people will start collecting it in the bio waste and industrial compost. But having said that, I can also tell you that, as I mentioned in the slide deck, then we, the company, developed a solution for taking PLA and not only recycling it, but making more lactic acid and PLA out of it. So we don't rely on consumers. We don't rely on people to do favors to recycle the PLA. We can just take the stream and use it ourselves.
Excellent, thank you. Any other questions? Do we need to move on? Jacob, probably. Okay. I am going to move to the last speaker. Thank you, Amir. Much appreciated. The last speaker is his name or her name, I'm not sure, Shay Zeltzer. He's a post-harvest specialist, and the company is called ROP. It is a smart packaging for fresh produce company. Please tell us about your company, Shay.
Okay, now I'm unmuted now.
Okay, we hear you now.
Thanks for the introduction, Alexa. My name is pronounced Shai, although I spell it like Shay. If you can see my screen, what you see on the screen now is our plant production facility in the north part of the country in Israel, established about 40 years ago. So it's an established company. We're going to talk about food waste and modified atmosphere packaging. Speakers that spoke here before me already mentioned the huge amount of food waste. We're looking at 1.3 billion tons of food turns into waste every year. The majority of it is fresh produce, about 75%. If we dive into the numbers and look at
Shai, we're not hearing you. You're frozen.
where in the process.
Oh, you're back.
I'm back. Okay. So as we can see on this chart, it shows the distribution of the waste. When I'm moving your icons on the screen, do you see my presentation or yourself as well?
We see both. You're good.
Okay. So we can see that depends on the region. A lot of produce can go to waste in the retail side, in the consumers, so people buy more than they consume. But in any event, a lot of product that we grow end up in as a waste. It's in our hand to protect the environment. And in order to do that, to minimize the impact on the environment, it requires two things. The first one is to reduce food waste. And the other thing is to reduce the amount of packaging used. In some cases, you can hear populism calling for banning food packaging altogether. But the risk is an increase in food waste, and I'm going to talk about it in just a little bit. Just to make a comment here, fresh produce always makes it to the cashier in bags. So let's look at bags and think of how can we use packaging or bags as early as possible in order to minimize produce waste. I'll present here a brief axioms. Absolute freshness is a state that produce is in it at the moment it is harvested. Bad thing is that from this point on, the produce begins to deteriorate. The other bad thing is that this process is irreversible. But the good thing is that using post-harvest protocol, correct post-harvest protocol, and the right packaging, this process could be dramatically slowed. In order to do that, you have to understand fresh produce. ROP develops packaging based on hands-on vast experience in post-harvest and polymer engineering. The two works together. It all starts in the lab, post-harvest lab, where we test our films on various products. And then we continue working with growers, shippers, retailers, and research centers. You come with a solution and you have to find the right person along the logistics that will appreciate the benefit that you bring and will see it as a value for them or as a differentiator between them and the crowd. The packaging developed is produce specific, means no bag, there is
You are frozen again, Shai. Hopefully you'll come back here.
no.
One suggestion is maybe if we turn off our video.
Bag
oh,
fit.
it's back. if you can hear us, Shai, I would turn off your video. Maybe you can just speak without your video. And maybe there'll be more space.
I think Shai was
just disconnected.
Disconnected. He's not in the room anymore.
Oh, he's not even in the room. Okay. Shall we, let's see what we can do here. Is there any questions that are arising from the presentation so far? I think we're still trying to learn what the product actually was. I get that it's about preserving freshness for produce. I wasn't clear exactly what the product was made from. So I was very curious to hear more on that. So maybe Shai will pop in. That was our last speaker. Wanted to remind folks in the chat that all companies are available for one-on-one meetings tomorrow between 8:30 a.m. and 2 p.m. Pacific Standard. There's a link in the chat to register. So if you'd like to do that, please take advantage of that. Is there any closing questions for any of the other speakers while we're on here? I don't see any hands up and nothing.
Just one remark. The link.
Go ahead. Yes, please.
The link Ray sent is the working one. The other links has a dot in the end, so they're not leading to the right place.
Okay, excellent. So it looks like there's 2 links in the chat. You want to use, is it correct, the link from Ray? Is that the one? Okay, so it's the second link from Ray Roth. Please use that. It's a form to register with the one-on-ones with the companies tomorrow. I guess this concludes our session. Jacob, is there anything else that I need to remind folks of?
No, that's it. Thank you so much for moderating, and thanks everyone for being a part of it. We hope this was helpful, and we look forward to the B2B sessions tomorrow.
My pleasure. Have a great rest of your morning or afternoon, everyone. Please take good care.
Thank you.
Bye.
Thank you.